Hello friends, welcome to VK lectures. In this lecture, we are discussing the vector calculus topic from mathematical methods of physics. We'll be discussing about the gradient, divergent and curl. This gradient of a scalar. The gradient of a scalar gives you a vector quantity. Now in any dimension you can write the gradient of a scalar del phi. Phi is the scalar and del is the operator, is given by q1 cap by h1 into dou by dou q1 plus q2 cap by h2 dou by dou q2 plus q3 cap by h3 dou by dou q3 into phi. So this gives us the gradient of the scalar, and this qi, that is q1, q2, q3 are the axis or the direction or unit vectors in the corresponding coordinate system. For example, qi can be q1, q2, q3, that's equal to x cap, y cap, z cap. This is in Cartesian coordinate system, three-dimensional Cartesian coordinate system. And for spherical, polar and cylindrical coordinate system, you will have their own unit vectors. Now, and what are this h? Hi is the metric element corresponding to each direction, So this h1 will vary in a different coordinate system also. Now for three-dimensional Cartesian coordinate system, the del phi can be written as the q1 cap is x cap dou by dou x, and h1, what is the value of h1? h1 is equal to 1, h2 equal to 1, h3 equal to 1. This is for Cartesian coordinate system. So x cap dou by dou x of phi plus y cap dou by dou y of phi plus z cap dou by dou z of phi. So this is the x coordinate, y coordinate and z coordinate. Now for example, if phi is equal to x, y, z, phi equal to x, y, z, find del phi, which is equal to x cap into dou by dou x of x, y, z plus y cap into dou by dou x of, dou by dou y of x, y, z plus z cap into dou by dou z of x, y, z. and this is partial derivative. So dou by dou x of xyz means yz. So x cap into yz plus z cap into, this is y, so xz plus z cap into here xy. This is the direction, x cap z, this is y cap, or you can also write like this, I cap. So yz I plus xz j plus xy k, but it is better you follow some standard xy z. All right, now we have the phi is a scalar quantity. See, you do not have any direction to it. X, y, z is a scalar quantity. Now del phi, what we are getting, this is a vector. Now sometimes in the question it will be del phi at 1 minus 1 1. So you have to substitute for, this is x, y and z. So substitute for x, y, z, you will get the corresponding vectors. So in this case this is y and z, so minus 1 I cap, so minus I cap, plus xz, that is minus I, plus j cap, plus xy, that is again minus 1, minus k cap. So this will be the how you will be getting. So let us write this as vector A. So vector A is of this form, and more importantly, sometimes you may have to divide by the normalizing or divide by the magnitude of the vector. Normalizing means the quantum mechanical idea. Okay. So from this it is understood that it is a cylindrical coordinate system, and what is the values of h1 is equal to 1 and h2 equal to rho and h3 equal to 1, and the directions are rho, phi, z. So what we can write, del phi is equal to rho cap into dou by dou rho of rho z square cos phi. So this is the first term, plus phi cap into phi cap by h2, phi cap by rho, dou by dou rho, sorry, dou by dou phi, dou by dou phi of rho z square cos phi plus the rho phi and z cap by, here this is 1, this is z cap by 1, dou by dou rho phi z of rho z square cos phi. So let us write down each terms. This would be equal to rho cap into dou by dou rho, so rho will go z square cos phi, this is phi cap by rho into, with respect to phi you can write rho z square cos phi differentiation minus sin phi, let's see, here is equal to z cap into dou by dou z, so 2 rho z cos phi. Now you can write this in general, so z square cos phi rho cap plus this 1 by rho and 1 by rho, this one and this one gets cancelled, z square, so minus z square sin phi minus z square sin phi. What is the direction? Phi cap plus 2 rho z cos phi z cap, 2 rho z cos phi z cap. So find the del phi at 1 minus 1 pi. That is your work. So 2r square sin theta cos phi. So this is r theta phi. So r theta phi, this corresponds to spherical polar coordinates. Okay, now what we have to do, first we have to find the corresponding h1, h2, h3. h1 is 1, h2 is r, and h3 is r sin theta. And what are q1 cap, q2 cap and q3 cap? q1 cap is r cap, this is theta cap, this is phi cap, r theta phi. So what is del phi now? Del phi is equal to q1 cap by h1 dou by dou q1 plus q2 cap by h2 dou by dou q2 plus q3 cap by h3 dou by dou q3. This is phi, sorry, this is not vector phi. Let us take this as some alpha, some alpha. So alpha I just don't want to take phi again. Phi is, we have already taken phi. This is, let it be del alpha. Okay, so now what you can say, q1 cap, that is q1, that is r cap dou by dou r of 2r square sin theta cos phi. Then q2 cap, that is r cap theta cap by h2, what is h2? R, dou by dou r theta into 2r square sin theta cos phi. Then h3 q3, that is phi cap by r sin theta dou by dou phi, 2r square sin theta cos phi. So this gives us r cap into dou by dou r of this quantity, that is 2r square. 2r square means 4r's. 4r sine theta cos phi. This is equal to theta cap by r dou by dou theta. So sine theta will become cos theta. So 2r square sine theta cos theta cos phi. This is equal to phi cap. So phi cap by r sine theta. With respect to phi, so cos phi will become minus. So minus 2r square sine theta sine phi. Now this is what you have. Now this you have to divide. So that is 4r sine theta cos phi r cap plus this r and r get cancelled. 2r cos theta cos phi theta cap plus this one r sin theta will get cancelled. So 2r sin phi minus 2r sin phi cap. You can find del alpha at minus 1 pi by 2. That is your work. Here are few questions that you can try. The potential or the V, that is the scalar field, is given. You have to find out the gradient of the scalar field. Divergence of a vector. So how much divergence is there for a vector quantity? Okay, that's given by del dot a, some any vector a. So this gives us a scalar quantity. So from we have a vector quantity, and when you do the divergence you will arrive at a scalar quantity. Now for a general coordinate system, system, we have the q1, q2, q3 as the unit vectors, and the metric elements are h1, h2 and h3. Now how can you write for a general coordinate system the divergence? It can be written as for any vector a can be written as a1, that is the corresponding to the q1, a1 q1 cap plus a2 q2 cap plus a3 q3 cap. This is the quantity, the value of each quantity in each direction, q1, q2 and q3. Then you can write del dot a, that's equal to 1 divided by h1, h2, h3, then the bracket dou by dou q1 into a1 times h2 h3, a1 times h2 h3 plus dou by dou q2 a2 times h3 h1 plus dou by dou q3 a3 h1 h2. Please remember it in this order so that you will not confuse. So Now let us see for the first question number 1 for Cartesian coordinate system. Vector A is given as ax into x cap plus ay into y cap plus az into z cap. Now find del dot A at 1 1 1. So for Cartesian coordinate system, this is Cartesian coordinate system. By looking at the unit vector, I can understand that it is from the vector is in a Cartesian coordinate system. So let us start with 1 by h1 h2 h3. So for Cartesian coordinate system, h1 equal to 1, h2 equal to 1, h3 equal to 1. So this terms is 1. Now dou by dou q1 of dou by dou q1 means dou by dou x of ax. A1 is ax, so ax plus dou by, because h2 and h3 are all equal to 1, so dou by dou y of a2, that is ay, plus dou by dou z of az. Now here we do not have any terms corresponding to divide it, to differentiate. So what we will do, this will remain as ax ay, so we could have gone with some other ax. Let us write ax equal to x square. Let us take some values. Ax equal to x square, ay equal to some 2y, and az is equal to z. So dou by dou x of x square is 2x plus ay is equal to 2y, so that is 2 plus az equal to z, so that is 1. So 2x, so x value is 1, so that gives 2 plus 1, that's equal to 5. So this is here we have a question that is the vector a is equal to yz x cap plus xz y cap plus xy z cap. The question is to find del dot a, the divergent of a, that's equal to dou by dou x of ax, the coefficient of the x cap, then dou by dou y of ay, this is ay, the coefficient of y cap, and dou by dou z of az, which is the coefficient of x z cap. Now dou by dou x of yz, dou by dou y of xz, and dou by dou z of xy. So the first term does not contain x, the second term does not contain y, and third term does not contain z. So the partial derivative gives 0. So del dot A is 0. Now here is a second question. The first question is from three-dimensional Cartesian coordinate system, and second one you have rho, phi and z. So this is a cylindrical coordinate system, and you need to find del dot A at 1 pi by 2 minus 1. So this is the question. Please find the answer. Vector A is given to be rho sine phi rho cap plus rho square z phi plus z cos phi z cap. Now what we have to find? Del dot A. So del dot A is equal to, in general, what is that? 1 by h1 h2 h3 dou by dou q1 of a1 h2 h3 plus dou by dou q2 a2 h1 h3 plus dou by dou q3 a3 h1 h2. Now for cylindrical coordinate system, h1 equal to 1, h2 equal to rho, h3 equal to 1. So that's equal to 1 by rho dou by dou rho a1, that is this one, a1 rho sine phi into rho sine phi into h2 h3. What is h2 into rho? So into rho plus dou by dou q2. What is q2? Phi. A2 is rho square z into h1 h3. h1 and h3 are same, plus dou by dou rho phi and z. A3 is z cos phi. h1 h2, 1 rho will be there. So that's equal to 1 by rho. This is rho square. So 2 rho sine phi plus this term will go, this node, plus dou by dou z. So rho cos phi. So 1 by rho into this quantity. So here 1 rho is there, 1 rho. So 2 sine phi plus cos phi. Now what is the value of phi? Phi is equal to pi. So 2 sine pi, that is 0, cos pi is minus 1. The vector A is given as 1 by r square sine theta r cap, r sine theta cos phi theta cap, cos theta phi cap. Now question is to find the divergent del dot A at minus 1 pi by 4 pi by 4.